Hi, Nancy.
Hello, Shane.
All right. So today's question of the day, if money or resources or whatever weren't an issue, like if you could do whatever you wanted, what's the craziest place on Earth that you would want to visit?
Craziest place. I don't know where the craziest place. I think it would have to be kind of warm, but as you probably know, I love reading, and I would love to go to a place where there were like lots of bookstores that I could just hang in all day and just read books like on a remote island. I think there actually is one somewhere. They have like an outdoor bookstore somewhere, like, you know what I mean, like in a tropical place, and it's like I followed on Instagram. It looks pretty sweet.
Only you would answer, I want to go to an island, and it sounds amazing, but there wasn't exactly. Hey, Nancy, you do you.
So what about you then?
I think mine would probably be the opposite. I mean, reading's fine, but I'd want to go probably somewhere cold. I know I actually have a few friends who have been down to Antarctica, and that seems like so hot right now. But I'd want to go probably north. I don't know. I've been thinking about maybe like Greenland in the middle of winter. I want to be somewhere where I can ski and snowshoe and ride snowmobiles and be around snow.
That would be pretty sweet.
Yeah.
Have you ever heard of this place called Svalbard?
Heard of, but I can't exactly say it's been on my radar. Welcome to the American Geophysical Union's podcast about the scientists and the methods behind the science. These are the stories you won't read in the manuscript or hear in a lecture. I'm Shane Hamlin.
And I'm Nancy Bompey.
And this is Third Pod from the Sun. So why Svalbard?
Well, let's bring in our producer, Lauren LaPuma, to explain. Hey, Lauren.
Hey, guys.
Okay, so I'll ask you, why Svalbard?
Well, a few months ago, I met Kiya Riverman, who's a glacial researcher at the University of Oregon, and Kaia studies caves in, guess where, Svalbard. Svalbard is a group of islands in the Arctic Ocean, but kind of between Norway and the North Pole. It seems like a random place, but people live there, and there's actually a university where people do research.
Did you guys engage your ice feet?
So I, as an undergraduate, studied abroad up in Svalbard and was interested in doing some glaciology research and went to the main professor at the university there at the time and said, hey, how can I help? And he looked at me and was like, yeah, you'll fit, which I didn't understand at the time. But as it turned out, there was this cave system that he was doing a lot of work in, that there was this one really tight spot that he couldn't actually fit through. And so he was looking for people who could help with the project. And so that was my first time down in. And it was kind of the opening of a whole new world of research to me. It's at 78, 79 degrees north. So it's super high Arctic. And so that means that there's 24-hour daylight and there's 24-hour nighttime, and then transitions between that. And so I first went up there in the dark. So I couldn't see anything. And all we got was these like magnificent displays of northern lights and stars. Wow. And then the lights slowly started to come back, and you could see these huge mountains all around. And it was like the awakening of this beautiful Arctic landscape. And it's a little community up there. So the second you step outside of town, you're in this like vast, untouched Arctic landscape that has so many exciting research questions and research avenues to go down. And so that combination for me was just addictive almost.
Where are these caves she's talking about?
They're caves made of ice inside of a glacier.
What? Wait, she goes in there. Why would someone ever go inside an ice cave inside a glacier?
Well, that's one of the ways to study how water flows through a glacier from the top to the bottom.
So to study water under the ice, I go out to the middle of Greenland and Antarctica and blow up dynamite and measure vibrations that come back from the underside of these echoes. If I care about water on top of the ice, then I usually use satellite imagery. If I care about how water gets from the surface of the ice to underneath the ice, then I crawl around inside of glaciers and kind of study the ice from the inside out and look at the pathways that the water actually takes as it moves through the ice. So water, as it's cutting through ice, it forms these big, tall canyons, and then those canyons start to close above, like in the ceiling. So you walk and crawl through this kind of teardrop-shaped passage that is beautiful in a really otherworldly way. And I spent a lot of time studying the waterfalls, actually, that are within that system. So as it turns out, waterfalls matter inside of these glaciers. They're one of the big ways that the system changes in the way that water is transported from the surface of the ice down to underneath. And so we spend a lot of time roped up in a harness, kind of hanging off of these waterfalls, taking pictures and mapping where they are, and it's lovely.
So she's an ice caver. How does one go about becoming such a thing?
Well, Kaia did some caving in, normal limestone caves back in Pennsylvania, your neck of the woods, Jane.
Woohoo!
But these glacier caves are different because they're ice and not rock.
When you're caving in a limestone environment, being cold isn't such a concern. It's more like you're really warm and you have to manage that. But we actually have to pretty actively manage our own temperature inside of these systems. So maybe that's the obvious difference, but there are a lot of similarities. And I think I'm forever surprised by the similarities because you see a lot of the same formations of meltwater dripping and freezing that look exactly like limestone formations. And so it's kind of just like a muddy limestone world has all just been flash frozen into ice. And the comparison is more striking than the differences, I think. There are specific places where the environment is such that you form these systems, and Svalbard is like one of the big ones, and so there hasn't been as much work done really anywhere else. I would love to go to the Himalaya and crawl around inside of glaciers there, maybe someday.
So what's a typical day like for her down there?
Well, the first thing she has to do is get to the cave, which means she has to ski up the glacier to the cave's entrance, and then she climbs in and down.
A day starts, you strap on your skis, you ski up the hill, you leave everything outside, and then you drop into the cave. I always love that moment because it's this transition from this like brutal Arctic environment to a quiet, warmer cave where it's like we can sink into the beauty of it and the science of it and all of the distractions of the hazards of the Arctic environment otherwise just go away.
What does it kind of look like when you're in there?
Imagine like a cave that you would see in the limestone world with stalagmites and stalactites, but then change all of that to ice. And so you're in an ice cavern, and the walls are sometimes sparkly where you get air movement, and you can see your breath in front of you always. And you can see layers in the glacier, actually. So you can tell a little bit of its formation history and flow history just by seeing where is it deformed and how is the ice flowing. It's lovely. We're actually building maps by hand of these cave systems. And so there's not a lot of technology that works very well inside of these cave systems. Things like to freeze and break. And so what we found kind of by a lot of trial and error is that we do science in a very 1840s style, which is mostly hand sketching to scale these systems.
So do you have to be a good artist?
I don't know if I would claim to be a good artist, but there's a little bit of being able to like represent to scale what you're seeing like in the environment that definitely comes into play.
Yeah.
So we actually do use like laser rangefinders to get distances between points and angles, and so to make sure that everything we're doing is to scale. Mm-hmm. But then we travel through the system and sketch it as I go. Mm-hmm. And I've worked with people who also do structure from motion photography, which is you like take a picture of an object from a bunch of different angles and then use that to make a 3D point cloud that lets you later on go in and do a lot more kind of detailed analysis of the system. But even that sometimes doesn't go very well. So we always come back to these hand-drawn sketches, which are, we can go in and digitize them and then compare year after year. How is this system changing?
How long will you spend down there, each time you go in?
Usually it depends on how long you can stay warm. So, sometimes we go in for 4 hours and can get done what we need to do. And then there have been times that spending 17 hours down in there.
Wow.
And then after that, it's always a real shock to climb back out and see that it's nighttime and have to ski down the glacier again.
Is there any time where you're up there where you're just like, it's so cold, I have to get out of here. It's so cold and so dark, like I have to get out of here now.
Yeah, but then as soon as you get out, you have like a beautiful ski back down the glacier, and it lifts your spirits right back up again.
Does she go all the way to the bottom of the glacier? I mean, what is that like?
Well, yes, she does actually. This particular glacier in Svalbard is about 60 meters thick. That's about 200 feet. So she and her colleagues, they climb all the way down that 200 feet to the very bottom, which is the bed of the glacier.
Glaciologists spend a lot of time trying to study the bottom side of glaciers.
Oh, look at this.
And it's so hard to do. You can imagine in most places, you're standing on the top of this ice, and there's, in Antarctica, there's a mile of ice between you and the bed. How do you actually study down there? And that's one thing I love about this work is we can actually go there and take samples and do measurements, and that's just a unique privilege that it's easier to think about when you're not army crawling through rocks under the ice. But when you get out later, to marvel in kind of the opportunity to study them from the underside is great.
When you're down there at the bottom, do you ever feel claustrophobic in a way, and you're like, oh my God, there's tons and tons of ice sitting on top of me right now?
Yeah, only when I start thinking about how the channels are actively closing. Even while you're there, the ice is always creeping closed, just at a really slow rate. But there are moments where you've, squeezed through something small, and that part of your brain is like, oh man, I know it's closing, but it's
not going to close on you.
It's not going to close on you. It's not fast enough to ever be a concern. But some little part of your brain is like, oh, it's still closing. Maybe I shouldn't spend all day down here. I think there's a fear. I think people are scared of the idea of going into and underneath these glaciers. But we know how to be safe in them. And so that means it's not a scary place. It's just a real opportunity to study these beasts from the inside out.
So how many times has Kaia been down inside this glacier?
She's been to this glacier 4 times in the last 8 years, and she's actually seen it change quite a bit.
That's one of the nice things about going back regularly is that kind of on a year-by-year scale, you can stand in the same point and go, oh, last year the cavern had this shape, and now I can see exactly how it's changed this year. And the overall trend that we're seeing is that the waterfalls are growing together and getting bigger. Mm-hmm. So over time, they start really small, and they grow bigger and cut in faster to the ice. And that could be due to more water entering the system, so more melt that's occurring. Or it could just be part of kind of a cycle of these channels forming and evolving and then closing over time.
So, and what will that tell you about how the glacier's changing?
Where you can find water under the ice, that water has an impact on the way that the ice flows. You can imagine a wet ice cube sitting on a table. It's going to slide around a whole bunch, and a dry one just sits there. And really what I'm doing is showing where does water that we see on the surface of the ice, and we see it, dropping into the system, where is that actually coming into contact with the bed? Mm. And so by mapping over time where that point is, it tells us how this glacier how its flow in the future might change. Because if the area downstream of wherever the water is reaching the bed is able to flow faster, we're showing how that point is progressing through space.
This sounds so super cool and adventurous. Has it inspired Kaia to do other really super adventurous things?
Yeah, I don't know how you would get more adventurous than ice caves, but she told me she has become kind of a mountaineer.
My partner and I spend a lot of time doing mountaineering and skiing, and recently we got into canyoneering in Utah mostly. Mm-hmm. And there are these canyons that remind me so much of ice caves, actually, because they have the same kind of layering that you see in the walls and very similar morphology or shape of the canyons. And it was fun to go do this canyoneering and realize that like my skills that have come from years of ice cave work could like translate to this fun new sport. So yeah, it definitely has influenced the rest of my life.
Oh, that's so cool. So which one is more difficult then?
I think ice caving wins for the cold factor.
Yeah.
Yeah. Plus, it's really novel to, in canyoneering, be able to like not have a headlamp. It's like the best of caving and rock climbing combined because you can see what you're doing.
What's your favorite thing about doing this kind of work?
So this has always kind of been a side project for me. My PhD was based on studying ice streams in Greenland and how they move and change. And this has always been a fun question on the side that is like my own ideas. So it's not like I have an advisor who's giving me projects, or it's been just my own getting to do science, getting to ask questions and then go pursue them and write grants and get them funded. And I think like even as an early grad student to have that experience of being able to ask my own questions and make it happen and do the field work and work on publishing the results. And it's been really empowering.
I have a confession, guys. I thought Svalbard was a made-up place until about a year ago.
Well, I mean, I can barely pronounce Svalbard, so.
Why did you think it was made up?
Because a long time ago, I read The Golden Compass, which takes place in an alternate universe, and they go to Svalbard. And so I just thought it was an island made up for that book. I didn't think it was a real place where people lived.
That makes sense. Maybe you could read that book about Svalbard in a remote bookstore on an
my gosh.
island
Oh, Nancy.
with me.
Okay.
I'd rather just go to the beach, Nancy, if that's okay.
All right, folks, that's all from Third Pod from the Sun.
Thanks, Lauren, for bringing us this story, and to Kaia for sharing her work with us.
This podcast is also produced with help from Josh Spicer, Olivia Ambrosio, Caitlin Camacho, and thanks to Kayla Surrey for producing this episode.
AGU would love to hear your thoughts on this podcast. Please rate and review us. And of course, you can always find new episodes at your favorite podcasting app or at thirdpodfromthesun.com.
Thanks all, and we'll see you next time.